So should you use Azure Resource Manager templates or something like Terraform for your environment? And this is a very environment-specific question, and it's going to depend on what you're currently using. If you're already using ARM templates or Azure Resource Manager templates, then you can go ahead and continue using them. But the big difference is ARM templates are built for Azure. They deploy resources inside of Azure. Terraform uses the HashiCorp configuration language, and it can deploy across multiple clouds. It's kind of cloud agnostic. It uses a provider and resource model, whereas ARM templates only deploy Azure resources. So if you're trying to deploy across a portfolio of clouds or a portfolio of environments, even on-prem environments, Terraform would be a really good choice. Now, if you're already using ARM templates and you want to look at something like Terraform, that's totally cool and that's great. You can actually deploy ARM templates using Terraform. Terraform has a resource to deploy an ARM template. So say you've already got one and you're using it now, you can still use it and you can start transitioning into Terraform if need be.
Hey there! Welcome back to AzureFunBytes. My name is Jay Gordon. Once again, I'm coming to you live from Brooklyn, New York, where I try almost every week to have a conversation with someone about the different fundamental parts that make up Microsoft Azure. So have we talked about this in the past? Absolutely. Is it important to continue to talk about it? It's monumental. But today we're going to talk again about Terraform, which is a tool to build infrastructure, deploy applications, all these different things we can do with it. And today I've got a guest. He just stepped away for a sec, but I know he's going to be back in a second. But it's Zachary Deptawa. He is part of the Azure advocacy team. He will help me today go through more about HashiCorp Terraform. And so just to kind of get started, I want to tell you all, thanks again for always taking part in this show. Know that you are a part of it. And by saying that, if you'd like to, leave comments below. If you're in Pubble, in Learn TV, we're going to have Pubble soon. You'll be able to leave live comments there. I think we're going to be doing a lot of really cool things coming in the future with AzureFunBytes. So I want to thank you, as usual, for giving this your all, watching it, looking, listening. And so, like I said, my guest was here, but I think he's having a technical issue. So we're going to get started with him in just a second. I'm going to turn off my little background music because I don't think we need it right now anymore. Great. So, welcome back, like I said, to AzureFunBytes. We are going to take a trip around HashiCorp Terraform today. And in order to kind of get started, what I'm going to do, let me bring this over here, is I'm going to bring up a little something here in our screen. And please allow me some patience while I do this. Cool. So we're going to talk a little bit about Terraform with Azure. And I think it's going to be an interesting conversation. Zach is restarting his computer. When you do it live, sometimes these things happen. Anyway, Zach will be back with me in just a few minutes. But like I said, today we're talking about Terraform on Azure. And Terraform in Azure is an open source tool for provisioning and managing cloud infrastructure. And as they say, it codifies infrastructure and configuration files that describe the topology of cloud resources. And these resources include virtual machine storage accounts, networking interfaces, and the Terraform CLI provides a simple mechanism to deploy the version configurations files. So let's stop for a second and talk about the portability of Terraform and why it's really cool. I am going to open up a terminal here in VS Code. Cool. And then what you're going to be able to see, at least what I'd like you to be able to see here, is the ability that you'll have to actually work with Terraform in almost any environment, and that's kind of what I wanted to show you. So first and foremost, if you are using Visual Studio Code and you'd like to work with Terraform, what you can do is go here and you'll see we've got a Terraform language support within your use of VS Code. So we can go ahead and click install. We can also, I've got one already here. It's an official provider from Terraform. We've got one from 4ops. And then we actually have an Azure Terraform VS Code extension. So it's really cool that we have these tools that allow us to integrate Terraform right here in VS Code. And now we're going to look here in my local terminal, and we're going to do Terraform. And so as you can see, Terraform is also here on my local computer. So I'm able to use this here in Visual Studio Code. So if I have some Terraform content that I want to have highlighted, what I can do is, let's go here to GitHub. I will go and I will go to the Terraform Provider for Azure, and just so you can see it as an example, I'm going to go here. I'm going to copy where the repo is, and then what we can do here, I'll just do it right here. So cd here, git, little computer slowness, sorry about that, git clone. Let me make sure it's a little bigger so you can see it. Let's get rid of this key bindings warning. Sorry about that, everybody. And we'll git clone. And so here is an example Terraform provider for Azure VM, all the GitHub repositories. And so the reason I'm showing you this is I want to just show you the portability of Terraform and the different places that you can run it and work with it. And so in this particular case, I've got all these files. So let's go into Terraform Provider Azure VM. And we'll git pull. Just make sure we have it. Yep, so we have the latest version. So now let's open this. And here's our directory with our Terraform provider. And what I'm going to do, just to make it easy on myself, let's go here. And Zach, I think, is back. Let's add him to the stream. Hey, Zach, how you been?
Oh my gosh, Jay, I can't believe the timing. I don't know if you saw my messages there.
I did. I saw your Mac, unfortunately, said goodbye for a few minutes. You know,
It did.
as I said, when you do it and you do it live, sometimes these things just happen, right?
Yeah, for sure. So let me do this. I'm going to get some things reopened on my side real fast.
Sure. Go. I'm just talking to people right now about like the portability. I think that is amazing about Terraform. The fact that like I'm showing it in a number of different places on my computer. So I'm showing that we can work directly with Terraform and Visual Studio Code by using the extensions. We actually have some particular extensions for Azure specifically, which I think is super useful. And then what I'm going to do is just show some of the syntax highlighting that we have. So I went ahead and I opened this up. I'm just going to dump it into Visual Studio Code. We'll bring over my new window over here. I, one of these days, have to use that highlighting extension where you can actually add like color coding to each individual tab that you have open. But anyway, that's neither here nor there. Let's go ahead and let's look at the Azure API management Terraform plan here. And what we'll see is we've got all this syntax highlighting that's built into Visual Studio Code so that we can work with this like we would work with any other piece of code. That's the whole point, right, Zach?
Yeah, and it's I mean, infrastructure is code, right? Like you want to basically express or declare your code, your infrastructure as code. And of course, Terraform is host agnostic provider. Tons of providers out there. You're absolutely right.
Awesome. So the other place that I want to show everybody that it makes it really easy to work with Terraform, and sorry if I'm looking down, everybody, but I have like 3 screens going on here. Like I said, when we do it live. It is a ton of things to do. So I'm going to bring up this application window. Let's go here to the GitHub providers. And so I've got my nice handy dandy Cloud Shell here. Cloud Shell to me is one of the best parts of Azure. I love it to death. And one of the things that we've talked about before is that Terraform is right here built into Cloud Shell. So what we've got is Terraform on my local computer if I need to work with it, if I need to do some syntax highlighting, if I need to be able to get some code snippets, if I want to make sure that my all my code is actually like correct and some syntax correction. What we can do is work with these extensions within Visual Studio Code that'll make our experience a little easier. And so we're going to take a look real quick at how we would begin, say, initializing something with Terraform. So I'm just going to make dir tfafb right here. And then, Zach, whenever you're ready, let me know. And
For
then
sure.
if I'm right, I can go Terraform init here, correct?
Yes.
And so that's going to initialize. The directory has no Terraform configuration files. So if I do an init, it's just going to look inside the directory and say, well, I've got nothing to work with. And so based on that, what we're going to do is need to actually give it some instructions. And so what I want to do here is actually configure the provider. And I can do that in my initial config file, correct?
Yeah. So you configure the provider either in your main.tf file. Some people put it in their variables.tf file. As long as it's in a .tf file, Terraform will.
Sure. So I'm going to bring back up my whole monitor that will include my Visual Studio Code and what we were working on here. So here is the directory with our Terraform built into Cloud Shell. Here's this. So what I'm going to do is go here to the documentation for Terraform, and you'll see we've got this Azure RM, which is the Azure Resource Manager, which you can use to obviously manipulate ARM. And then we've got our Azure Provider. And so the Azure Provider is going to handle authentication and work with our actual account. Am I right?
Yeah, that's exactly right. And actually, I have everything loaded back up, and you kind of are at a perfect spot if you want me to.
Sure.
Let me take over.
So that sounds great. So I'm going to stop my screen for a second, and then let's bring up yours.
Yeah.
Cool.
So, sorry about that, everybody, about the disaster of having to redo that. And Jay, I apologize. But the last time
you do it live. These things happen.
Oh yeah, it's how it works, right? That's how live demos are most of the time. So the last time I was on AzureFunBytes, we actually went through this demo right here, and I'll just show this really quickly because you were talking about the provider. We configured the provider the way that I was doing my authentication for that provider, and I know you just talked about Cloud Shell will already auth you, which is amazing. But the way that I do my authentication, because I'm just so used to it, is I use this envar.sh file. And what this is, I'll show you this sample. I don't want to show you my actual credentials. But a sample of this, I'm actually exporting some environment variables: ARM client ID, ARM secret, ARM client secret, ARM subscription ID, and ARM tenant ID. These are the important ones right here. So that's a way for me to export my authentication. Obviously, it wouldn't be asterisks. It would be the actual.
And so if you created a service principal username and password, correct?
Yeah.
And I want to show everybody, if you don't mind, how easy. So creating a service.
So actually, I was gonna demo that because last time I was on, we showed this. We showed the provider. We showed it working, but I didn't show what authentication means on Terraform.
Sure.
And how we actually set it up. Unless you'd like to demo that, that's fine.
Yeah, let me show everybody really quickly how to create a service principal, and it's super simple. I'm gonna have to do it pretty quickly because honestly, I don't want to give you all the ghost.
No,
I don't want you to see the username and password that's generated in here. So let's go here. recursion. Let's avoid that recursion. And so here's the doc that we have here. Create an Azure service principal with the Azure CLI. Super, super easy to do. So let's go ahead and go here. And we're just going to copy and paste that line. And so we can do an AZ create. And so, I don't have privileges for something. So it looks like I have an existing application with that name. So all I got to do is change the name. So what I'm going to do is call this a Terraform Provider. And that gives it just a name. And so now it's going to create this username and password, which I do not want. I'm going to invalidate this. Doesn't really matter. So congratulations, everybody. You saw it. It's going to be gone. Anyhow, this is how you would create the service principal that eventually is going to be used for our application to connect to Terraform from Azure. So I'm going to go back to you, Zach.
Okay, cool. So now let me see where I am here. I'm sorry, I'm still kind of all over. What I wanted to do was show that auth demo. Let me get Visual Studio Code open really quickly. I'm in a brand new directory here. So I really didn't step through authentication. I didn't step through how do you get started last time. I just kind of showed it working. So I wanted to run through it really quickly. So like I said, you can create a main.tf file. And inside that main.tf file, if I go look at one of my, actually I don't need to do that. Let me just do this. I want to configure a provider. And so a lot of people have, and I'm going to copy and paste some blocks of code so I don't have to type them out. But a lot of people ask me, I get asked this question a lot, when you are authenticating, you don't put your subscription ID, your client ID, your client secret, your tenant ID inside the code. And that's absolutely right. You never do this. You could do this. You could put the actual code here and it would work, but you'd never want to put this inside of a Git repo. You'd never want to share this information out. But I actually have some credentials that were created.
Well, that's good. It's always useful to have something beforehand. That's what I like to do. I wanted to show everybody how we created those credentials, on the fly. I think it was really useful because these are the things that, when you're building something, it's not going to be ready to go unless you've already created. So
right.
I always like to make sure you give you a little bit of look into what's going on.
For sure. And so I'm going to paste, I'm going to do what you should never do. I'm going to paste actual data right here. And this is my demo data. Just like Jay said, this is going to be invalidated shortly. So if anybody wants to mess with it, it'll go away shortly. But so I just created this file. I just saved it. So this is actually going to authenticate. And this is where I am. You can see this main.tf file that I just created. And if I do a Terraform init, in here, I haven't done anything yet. So it's just going to initialize the backend. It's going to initialize and pull down the plugin for Azure RM. And you can see that it works. And I'll do a Terraform plan. There's nothing that's going to happen, but it is authenticating in this step. So it just shows that my authentication works. And if we wanted to, and I'm gonna expand on this a little bit too. But if we wanted to, I could create a resource. And let me just go steal another snippet of code right here. Like if I wanted to create a resource group.
That's the one thing I want to stop for a second and just remind people. One of the things that's really awesome about Terraform is the fact that there are so many code examples on how to do the things that you want to accomplish. Just wanted to go back to that GitHub repo. Let me find it right here. While you're futzing around, I just want to show everybody this GitHub repo, which I think is real. Let me get myself. I don't want to recursion more, but the fact that is we have all these examples here within GitHub, and we can use these in order to actually accomplish these little goals that we want in order to actually build a batch job, build Azure monitoring. There are all these different pre-existing code snippets that we can work with. So if we want to create a container instance, we've actually got all the different provider instructions for that so that we can create multiple containers. We'll look here at the main.tf. And if I'm right, Zach, we can link all these individual plans together.
Yeah, for sure. I mean, you can basically copy and paste what you need where you need it. And we'll actually go into modules here in just a little bit, which is pretty neat. A pretty neat thing that you can do because nobody likes copying and pasting code
Hey, Zach,
if
so we have a
possible.
question. Someone wants to know if we're going to be discussing landing zones, or is this more of a basic intro? Do you think you could at least touch on it for a second, what they are?
So honestly, I'm not sure what's being described there. Let me pull this open. Let me take a look at this really quickly to make sure I'm understanding.
Let's see, landing zones. Oh, okay. It looks like that's an Azure specific, and it's part of the cloud adoption framework. And those are a multi-subscription environments for accounts for scale. So we're not really going to be covering that. Sorry, today we're mostly just going to be talking specifically about building with Terraform on Azure. So thank you for watching, and that's something that I'm going to keep in mind for the future. I appreciate you asking that.
Yeah, that's something that I really don't have experience with, so I need to dig into that myself. So
Yeah,
that's something we can do future.
yeah, absolutely. And it sounds like it's just a big Azure concept aside from just being a Terraform specific concept. So I think that's really cool. You got us to think about something new. So thank you very much, Systemic Admin.
Yeah, for sure. No, that's awesome. And I'm usually like kind of surprised when I run into something that I haven't really played with, just because I'm in this so much. But just showing here, right? I added that resource group into here. You can see my auth is still up top here. So I'm just going to show that I can build this really quickly. I did a Terraform plan. I'm going to do a Terraform apply, which will basically rerun that plan, show me that same output.
Can you do one up for the size? Just so we can.
Oh, can I do one up? Yeah, sure.
Yeah, +1. Yeah, there, perfect. Thank you. Just because I know I'm old.
No, it's good. I always struggle with finding the right size for.
Yeah. I mean, it's a presentation thing that we always have to deal with. I think every time someone does a live presentation, the one thing we got to make sure is, can everybody see it? And it's always just it's a back and forth. But thank you. I appreciate it.
Yeah, not a problem, man. Not a problem. I'm just going to have this build just to make sure everything's working fine. And as this is building, I can actually go to my portal that I do have open. Let me check out my resource groups, and we'll see this thing get created here shortly. Mm-hmm. So the apply is complete. I added that resource group, and if I can hit my Alt-Tab properly, if I refresh here, it'll pop up shortly. And we called it AzureFunBytes auth, I believe.
Mm-hmm.
Let me see. Let me make sure I named this AzureFunBytes auth demo resource group, and it's not showing up for me. That's interesting here. Hang on one second.
Sure. So while you're doing that, I want to just show everybody something I did.
Okay.
So while we were kind of like, ooh, I keep turning this on. Sorry about that. So one of the things that I started working with is I wanted to go into the main documentation. And while Zach's getting his ready, I wanted to show you how I went ahead and I got the provider for Azure created. And we can see here's like the version of the provider. This is all commented out because unlike the way Zach did it, I'm using the Cloud Shell. And that's automatically authenticating me for Terraform. And so what I can do, I think I created a state file. Let me just remove these. So these are just state files that get created when you work with Terraform. And so what I'm going to do is just delete these. And now you see I've got this main.tf file. And so let's say I just put this in here. And so we'll do Terraform init main.tf. No, excuse me. I just need Terraform init. My apologies. And so what it's going to do is now it's going to start initializing this directory with the providers. Version contains blocks or deprecates. So this is an old version of the provider. And so now we'll look in here. We've got these lock files that have been created. And if I wanted to, I can now do Terraform plan. And it's going to actually go ahead and start building what was in that main TF. Let's see. There's a here is actually the output of the things that we're going to be. So Terraform will perform the following actions. So it'll create a resource group. It'll create a test virtual network with 10.10.0.0.16. So let's look at what that looks like in that main file. And what we can do is just do code main.tf. And like we just showed, provider, Azure RM, the version, the resource group that we wanted to create, the name of the resource, the location it would be created, and this virtual network. So that's just some basics of how we kind of get started building our main authentication. And Zach, I've got you back up.
Okay.
And now I guess it's time to show that next step.
Yeah.
So we're off. And
Yeah.
in this case, I built a network, but you've got more to show me than just authenticating, building a resource group in a network, correct?
Yeah, for sure. But really quickly, I want to show one neat way that you can pull these out. If you're not used to using environment variables, you could actually go over here, create a terraform.tf vars file. And what's cool about this is the TF vars that you could exclude in your, you could put it in a git ignore, basically. You could have these files locally. They wouldn't be pushed up into to your environment. And what I can do is I can copy out these variables if my copy and paste wants to work for me. Doing it live, right? There we go.
Absolutely.
So I can copy this out. And now I've got my variables outside of my main.tf file. I can actually turn these into variables. So like var.subscription ID. I can keep this pretty consistent here. var.client ID, var.client secret. And I'll run through this pretty quickly. And the next step is really what I want to show you guys, which is talking about the back end. var.tenant. So now I've moved these out. I don't have these variables declared yet, so it will be mad at me for that. So let me create a variables.tf file. And you just simply say variable and give it a name. We've got subscription ID that I need to declare. We have, and actually I think I have this copy and paste, so I won't have to bore you with doing that. Let me find it here.
I'm not bored at all. I'm learning, and so are the guests, or our viewers. So we got a question.
Yeah.
Can you explain why you use TF-vars instead of variables.tf file? And that's from Systemic Admin again.
Sure. So the variables.tf file, and there are a ton of ways that you can do this. So anything that's .tf is going to be looked at by Terraform and used as a configuration file. A .tf vars file is a Terraform variables file. And the reason that I split stuff out, and I don't do this myself, but the reason that I split stuff out in this demo is I can now add this terraform.tf tf var files. So excuse me, terraform.tf vars file to a .gitignore file. And so these things will not be pushed into my repository. Whoever pulls this code base down will have to reset these variables, and that way it will continue to keep the variables.tf that I've. This is where I've basically declared those variables for use inside of my main.tf file. So it allows me to split that out a little bit. And like I showed earlier, I prefer to use environment variables. You can also use like the AZ CLI for auth. If you log in via AZ login, you would be authed as well. But that's why for this particular demo, I've split out terraform.tf vars and a variables.tf file. I want to ignore this. I don't want to push this up into a repository because these are secrets that we don't want to share. And so now that I've got this, I've got these set to variables. I have declared my variables. I have set the variable values here in my TF vars file. If I save this, I should be able to Terraform plan again. And it's going to do exactly the same thing that it just did before. It's using the same authentication, but I've switched up the way that it's working inside of my code. So you can see there's no changes to make. That resource group already exists.
Gotcha.
So that's great. And now what I really wanted to show here before we get into modules and things like that is I'm currently tracking my state locally on my system here, which is awesome if I'm testing. But it's not awesome if I'm working with a team, because that means my state will not match someone else's state. If we're trying to work on the same environment, that's no good. We need the state file to be a centralized remote place, which can be console, it can be Terraform Enterprise, but it can also be Azure storage. And so what I want to show real quick is how we can create, and I hope this works because I had to reboot my Mac, but how we can actually go through and create that storage information. And I have, let me show you guys this real quick. I already have a storage account here. It's under ZDepTow test for me. Let me find it here. There we go. And so this is my storage account. It's already created. We could have created this with code if we wanted to, but we can see that there's no containers here right now. So what I need to do is create a container, and I can do that with this code right here that I've copied and pasted. I'm going to grab right now my key that's going to be needed, my access key.
Okay.
And then I'm going to create this container, and I'm calling this container AzureFunBytes, and I'm putting it in that account name, and that's my big long account key.
Gotcha.
And so now that I've created this, it's created true. Let's go take a look at the portal and make sure it shows up for us. And there it is. So we have our container. There's nothing inside of it right now. But what's really cool is I have this code base. It's already running. It's using a local backend, but I want it to be a remote backend. So let's add a Terraform configuration block inside this main.tf file.
Okay.
And to do that, and I've got my copy and paste magic that so we don't have to watch me typing it. But I'm going to add a Terraform block. That lets me do a couple things. I can set things like a required version. I want it to be greater than or equal to .14, which is the latest that I'm on right now. And I'm setting my backend for Azure RM. I'm setting my resource group name, my storage account name, my container name, and whatever I want to call that key. I'm going to call it Terraform.tf state because that's what it's called locally. I could literally call it whatever I want to call it, but that's the key that people are going to want to use for their backend if they want it to match my own. And so now that I've done that, if I run a Terraform init again, you'll see it's initializing the backend. And this is on a code base that already exists. We've already got something built in this code base. And I do want to copy the existing state to the new backend. So I wanted to show this because some people have come to me and said, hey, I want to use a remote backend, but I don't want to have to redo everything that I've already done. You don't have to redo everything. You can tell it to push your state into that location and start tracking it in that remote location. And this is really powerful because this is kind of the next step for people that are starting to dabble in Terraform, how to get into a more centralized, team-friendly state. And so now if I do a Terraform plan...
Yeah, because we rarely work in a silo nowadays. We as an individual, we typically in any almost DevOps, ops, whatever you want to call it, even in just standard software development, we tend to not work by ourselves. A lot of different people are taking on different, especially if you're in on-call rotations and you're not the only person that's responsible. You've got to have ways to be able to share things like state files, and or it's just as important as being able to share updates to your code, and it's why we use GitHub.
Right. Yeah, it's the same principle, right? Like making sure that you're not stepping on someone else's toes and making sure that your state matches with everyone else who's working on that infrastructure. And so you can see the Terraform.tf state has been pushed up into my AzureFunBytes that I just created. And it's as simple as that. Now, everything that I do in this code base is going to be tracked in Azure. It's not going to be tracked locally in my tf.state, my Terraform.tf state file. So I just wanted to show that really quickly, show if you're starting out how you can move those provider details into something that you can ignore, how you can use an export to do that, and also how to get that backend set up. And this is just one example. There are a ton of examples for backends that you can use for Terraform. But this is how you can do it in Azure really, really easily. And so now that we've talked through that, I did want to jump back to what we did before. So this is kind of a recap of what we looked at before on the first AzureFunBytes that I did with you. It just goes through like getting started with Terraform. We created resource group. We created a network, a subnet. We created everything that was needed for that network. We created everything that was needed for that VM that we were creating.
We've got a public IP. We've got the network interface that eventually is going to hold our IP or our security group, our external IP, I should say. So, and then eventually connecting it to a Linux virtual machine, correct?
Right. And something that I want to mention, just in case anybody's new here, what I really love about Terraform is the syntax interpolation. So you can see that I have a resource group and I've given a location of West US2. Well, instead of copying and pasting that value everywhere, I could do it in a variable, but I could also say, when I go to create a network for my resource group location and name, go ahead and look to the Azure RM resource group AzureFunBytes resource group .location and .name. So I'm using syntax interpolation here. So it's pulling these values from this block of code, and that's super powerful.
Kind of reminds me of like Ruby and how Ruby will take those different variables that you set and then allow you to kind of chain them that way for interpolation. It's very familiar if you've ever worked with any other types of scripting languages and code. So
Yeah.
Makes sense to me.
Yeah, no, and it's awesome because, like I said, if you're copying and pasting this value everywhere, that will work.
Mhm.
But when you want to, say you want to redo this code and change it to East US or something, you have to do a find replace, which should work. But if you miss something, if you miss a file, you're going to have things that are kind of disparate and not done correctly. So you really want to reference one single place. I could actually make this West US 2 a variable and then still do syntax interpolation. So if I ever change the variable name, I change it in one spot. I don't change it all over the code. So it's really powerful. That also kind of builds a dependency. So now this resource knows it's depending on this other resource.
So let's take one quick question.
Yeah.
Well, let me ask you one quick question. In other configuration management tools or infrastructure as code, we work with a domain-specific language, a DSL. It doesn't look like we're working with one. We're using what's I believe is called HCL.
Yeah.
Can you just give us a brief, like the big difference between using a DSL and using the HCL that they provide you with?
Yeah, I mean, HCL is just the HashiCorp configuration language. It's the syntax that HashiCorp chose and uses, basically the syntax that they built here. But you can see it's superhuman readable. And the cool thing is no matter what no matter what provider you're working with, be it something like AWS, Azure, Google, Kubernetes providers, it's all using that same syntax. So that's
Gotcha.
kind of the power. You don't have to. Terraform is kind of abstracting away the need for you to learn these APIs for every service. You only have to learn how to talk to Terraform, and it talks to the APIs for you. And so
Gotcha.
that's the power. You can use it on any provider. You can build your own provider if they don't already have one. And it's the same commands: Terraform init, plan, apply. It doesn't matter what provider you're talking to. And the code, the syntax is always going to be HCL.
Gotcha.
So looking at this though, right, we step through all of this, and you can do this. You can get very granular. You can step through all of these things. You can see I've also created a network security group so I can allow port 80 access. The public IP, I have to actually create it, and then I have to associate the IP, and I have to associate the network security group. And there's all these things I have to do. You can see I'm creating the VM here, and I'm running a sample script. But this is 135 lines of code. It's not terrible, but what if we could bottle up some of this code and reuse it? Think of like a function or a method in standard programming. And this, just to show, this is actually the output of that code. So if you clone my repository and actually do a Terraform init, plan, and apply with the proper authentication, you'll be met with welcome to Nginx. The server will build, and then that's that. So let's look at the Terraform Registry. This is where you can go to find information about providers, but you can also find modules. And so this is an example of a module right here, a block for a module. And this is actually the compute module that we're looking at. And so what this does is when you build modules, you're actually writing it in HCL, but you're allowing inputs, certain inputs, and it's going to give you certain outputs that you can reference in the code. And so you're taking all of this code. This basically builds VMs for you on Azure, and it bottles it up into a small block, like this tiny block that you see here. And just to show the power of that, I wanted to show, this is the code base we worked with before, 135 lines. This code base here is doing the same exact thing, but it's using a module. It's actually using two modules. It's using the network module. You can see we've condensed the network down into, what is this, 8 lines of code. And we've condensed the virtual machine down into, what is this, 14-ish lines of code. And so
the big reasoning why, and let's just remind everybody, the reason why this has been reduced, and can you show them the module directory, is that what we've done is we've told Terraform, let's go into a specific module that is within the context of this code repository.
Yeah.
So it will, where will that particular module be within the directory structure?
Oh, inside the directory structure. So let me get over to this. It will actually sit in .terraform modules. So this is
Okay.
where if you wanted to see that code, and when you use a module, if you look at that code base, let me get back to it really
Do
quickly.
me a favor, scoot your terminal up just a little.
Oh, sure. Let me squeeze it
The
down.
bottom, just bring it up like a little bit.
Yeah, let me squeeze it down so I can pull it up. Is that good?
A little bit more.
Okay.
There you go. Perfect.
Perfect.
Thank you.
Okay. Yeah, no problem, man. So if we look at this code, let me get back to it. Where was I? When we look at this code, I'm actually just saying, I'm calling it, instead of a resource block, I'm calling a module block. And the source is Azure Compute, Azure RM. So when I do the Terraform init, it looks at my provider and pulls that information down, but it also looks at what modules are needed, and it pulls them down from the module registry. And
So it'll look within the file system and say, wait, there's a space here for modules. Let me check modules and make sure that if I have a module I'm supposed to provide within this plan, here it is.
yeah, so if it has it in the registry, it will provide it. You can also give the source location to a local module registry or local module directory that you've created. So if you're building a module and you want to test, and it's not in the module registry on Terraform, you can also give that source location as well. But it's really powerful because I didn't have to go download the code. I didn't have to clone it. I didn't have to put it in that directory structure. The actual Terraform init did all of that for me because it found it inside the registry. But not only that, I condensed all that code down, to 14 lines. The total code here is 68 lines, and I actually could have this last bit from 47 to 68. There is actually 47 to 64, excuse me. There is a custom options that you could do, and you can use Cloud Init inside of this compute module. I could have done that to do the same thing, but for the sake of time, I just copied this over for the demo.
Gotcha.
But really, I wanted to show you can bottle up code that you're going to reuse, and this doesn't have to be modules that already exist. If you have a particular infrastructure that you're running where you do a lot of like builds that come with web and database and storage and all of these things, you can bottle that into your own module and call it like module development or something like that. And then you can just use that small module to deploy that wherever you want to. So this is really cool. Modules are awesome to start working with, and really the way that I think about it, like I said, is like functions or something that you're going to continue to call inside of a code base. It's kind of the same thing. It's a logical block of usable code that's all kind of glued together.
Very cool.
Yeah, so that is really, and actually I could show you, right, that code does this same exact thing. The only thing, let me show you this really quickly just so y'all can see that it's not really smoke and mirrors happening in the background. So this is my AzureFunBytes demo. This is my demo 2. So this is built without my module. This is built with the module. And the only thing that the module does that I didn't do because it wasn't necessary for the demo, the module actually created an availability set for me. So for things like update domains and failover domains and all of that, when you wanted to get into the redundancy part, availability sets are really cool. There's nothing wrong with having it, but that's the only difference here is I have a single VM, so I didn't do that on my demo. But actually, it's kind of like a plus, right? I got more for way less code. So the last thing I wanted to talk about, because I do get asked this as well, is do I have to have several code bases if I'm doing, like if I want to stand up an environment and then I want to do something inside of that environment. A lot of people will do, they'll use Terraform to stand up the infrastructure, and then they'll use some other tool or scripting like Cloud Init or what have you to do work inside of that environment. But there are providers that are not cloud-based, and I wanted to show that. You can have a provider that works for something like Kubernetes, and this is a demo that I did a long while ago now at Ignite, and I just went through and cleaned it up and made it relevant for Terraform.14, so it's working in this code base if you clone it down and run it. But what this code does, and let me show you in VS Code because I like the way that looks better. But what's happening here, let me get to the right one. So this is that code base that I was just looking at. This is actually what I've already deployed because it takes a bit of time to deploy, but I've set my provider. Again, this is a demo, so I didn't do any of the fancy backend stuff. My backend is just local. But what I'm doing here is I'm deploying a Kubernetes pod. And so I'm using actually, let's go here. I'm deploying a Kubernetes cluster, excuse me. And I'm doing things, setting up the TLS private key here. I'm doing everything needed to deploy my Kubernetes cluster. and I'm still using the Azure RM provider for this. You can see that I'm using the resource Azure RM Kubernetes cluster, and I'm calling it K8s. But what I'm doing here is just getting that cluster stood up. It's standing up all of the nodes that are needed for that cluster. But once that's done, I'm actually using the Kubernetes provider in a separate .tf file, but it's in the same code base. So I'm standing up the cluster, and then I'm kind of switching to the Kubernetes provider to deploy pods and services inside of the Kubernetes cluster that I just stood up. And it's inside of the same code base, and it's under that single plan and apply. There's a lot of things that I've commented out because I don't need them for the demo. But you can see that I am setting up a Nginx pod, and I'm telling it to use the Nginx 179 image, call it Nginx, or the name is Nginx. And
I'm going to show everybody something really quick based on what you were just talking about.
Yeah.
And here is, we'll go back. This is the Terraform provider that you were just talking about. And you mentioned like the modules. And so what we can see right here are all these different products on Azure, different services that are all just actualized in a module directory within this repository. So you were just talking about using Kubernetes and AKS and building. Here is underneath the Terraform provider the examples to be actually use that Kubernetes module. And so what we can here see an Azure Container Instance connector, basic cluster, egress, network, all these different things that you typically would have to write Kubernetes manifests for. What we've had is it really simplified into several modules that you can just chain together and build what it is you need.
Yeah, and I think what you were just looking at there were the resources, but it's exactly the same thing. These are pieces to a puzzle that you're building, and you can go and grab those examples and put those pieces together, and then you can further compartmentalize those into like bigger modules that do much bigger things. But there's still it's a smaller amount of code to call that module that you've created. So it's a powerful thing. But yeah, there's really not a lot of cool stuff that we're going to see in terms of action here, but I wanted to show in this code base what I've done, and you can see that I actually have this. Let me clear this Terraform plan. Let me make sure that it's still happy after the reboot. Cross your demo fingers. Okay, here we go. And while I'm doing that, let me pull this up. So this is actually hitting that Kubernetes pod and the Nginx service that I created. And it looks like it's going to take a second to do this. I broke something.
When that's done, there's one other thing I'd love to see if you can kind of show off to everybody, because what we've done is like the initial infrastructure. I was curious, what if I need to pull down a GitHub repo or something like that?
Inside of Terraform?
Within our VM.
So if you were going to use Terraform to do that, I would do something after you stood up that server. I would either do that in a cloud init or actually do that in the same kind of block of code that I was using here, the virtual machine extension. And there's different types of virtual machine extensions that you can use, but you can see all I'm doing is I'm running this command that I want to execute. So I'm doing an apt-get update and an apt-get install Nginx. And that's why you're seeing just the Nginx page there. But if you use Cloud Init, you can give it the actual command block. So you could give it a whole list, like a whole bash script that you want to run. But Terraform is really, and I bet, if I'm not mistaken, there is a Terraform GitHub provider. Yeah, let's look at this.
Yeah, that's basically what I was looking is to be able to show people the power of these different providers and all the different things that you can do aside from just, Azure specific resource creation and manipulation, is the ability to actually integrate other services, other products, other needs into your actual initial configuration of your infrastructure. So if you actually needed something pulled down, because maybe it has some supportive scripts, maybe it's not the application, maybe it's some sort of bootstrapping process that you need done from a particular script. That's kind of the way I was thinking of it here.
Yeah, and just remember that Terraform is basically abstracting away the API calls. So as long as there's something that you can make an API call to get that job done, then you can do it with a Terraform provider. Even if that provider doesn't exist, you can write your own providers.
Gotcha.
This I'm actually looking at this right now. It looks like this is a GitHub provider to actually maintain or work with GitHub directly. So this wouldn't do what I was thinking it would do. But you would be able to do that using a code block or a virtual machine extension or cloud init block on a module.
Very cool.
But yeah, really, I just wanted to show that. I wanted to show that you can use multiple providers in the same code base under the same init, plan, and apply. I wanted to show the backend that I failed to show the first time, which would have been great for the initial. But it is kind of what I'm finding kind of a little bit of an advanced topic for some folks, and also how to abstract out that authentication. There's a lot of what I find like hesitance around the authentication piece, and it's really not that bad once you start playing with it.
Yeah, well, I've always felt with authentication in general is people they get worried about all the different pieces that go into authentication, especially when you're talking about something that's, I guess the best way to put it is enterprise level authentication, where you start talking about how you would, build these service of principles. And I guess that's the big thing that makes this easy is that the Azure CLI and the Cloud Shell itself is already off. And so, the power of Cloud Shell remains true. And so before we finish up, I just want to remind you all of how much Zach loves Cloud Shell.
So what is my favorite feature of the Azure Cloud Shell? So just aside from the ability to open up a Cloud Shell or a shell inside of your Azure portal, I would have to say my favorite feature is that we've packed some really good applications into the Cloud Shell for you by default. Not to mention that you just click a button and that shell pops open and is authenticated to your subscription. But we have tools, popular DevOps tools like Packer and HashiCorp Terraform. And that allows you to do things like take a Terraform code base, put it right into your Azure Cloud Shell, which is using persistent storage, by the way. And you can actually run that Terraform code. You can have it actually spin up resource groups, build VMs, build networks, all through that Cloud Shell. It's a great way to test really quickly if you've got some code, you want to see what it does, you want to see how it works. Really, really great resource. And also the Azure command line interface, the AZ CLI, is built in as well, and it's authenticated. You can use that to do things like check on servers, build things, anything you can do with the AZ CLI, you can do that in the Cloud Shell as well.
I really do love that.
Yeah, I love those tools. The thing that's really great about working with Azure is that I think that we've thought about a lot of different things for a lot of different people. And it really has made it so that more people can kind of jump in. And so let's say you need something because you're a Linux administrator and you feel comfortable with the command line. The Cloud Shell gives you that ability, and maybe you're a PowerShell user. That's another really cool part about this is you can just use PowerShell right in the Cloud Shell. But the reason why I mention it again is because Terraform right in the Cloud Shell lets you work with it, and you don't need to run it locally on your computer. You could run it in the cloud and make it super, super simple to jump into it. So Zach, we got about, 5 minutes left of the show. And so I'm curious, we're going to talk again in about 2 weeks about Terraform. And we're going to do it with members of the HashiCorp staff. And so the one question I have from you is what specific things have you seen come out of Terraform in the end of, say, 2020, beginning of 2021 that makes you excited?
I mean, there's a lot of changes that are happening, especially with Terraform 14. You can add new features. You can do depends on in different blocks. But really, what I'm most excited about and what I have the least amount of knowledge on, just being completely visible there, is console. And so console started as a key value store, and now you can do all kinds of things with it. There's the HashiCorp console service that's a managed service in the Azure marketplace, and I think we're going to dive into that a little bit in 2 weeks as well, right?
Yeah, I think so.
Yeah.
Very
Yeah,
cool.
I'm excited to see. Every time I talk to the HashiCorp folks, I learn a ton of stuff. So I'm excited to see what they have to bring. I did want to mention one last thing, though, if we have just a second.
Mhm.
For anyone who is unsure of what to do with authentication, just remember this is how I remember authentication with Terraform. If you're working locally on your say your laptop, you can authenticate with the AZ CLI. It's the easiest way to do it. Or you can create that service principal, or even a managed service identity is another way to authenticate. Of course, the Azure Cloud Shell is already authenticated, but just the way that I remember this for people, or I tell people to remember this, is a service principal or managed service identity. You want to do that if it's non-interactive, if it's going to be in a pipeline, if it's going to be automated. Obviously, you don't want to put your own subscription information into a pipeline. You want to do that in something that has role-based access controls. And so
Mhm.
if you're going to do it in an automated fashion, use a service principal or a managed service identity. Otherwise, just auth locally for what you're working on, and abstract that auth out of your code base. Never push that into GitHub or any kind of place where someone else might see it.
Gotcha. Well, you've given us a ton to think about, given us some ideas for how we can start, expanding our use of Terraform. And I think that we're all kind of always looking for ways to simplify the process of infrastructure deployment and infrastructure management. And so we've got 2 minutes. One of those minutes, I think you can show me how to just destroy everything. You think you can
Yeah,
do that?
yeah, sure. That's no problem at all. Let's do a. So this is my auth demo that we were just doing earlier. I'm just
Mm-hmm.
going to do not a get, a Terraform destroy, which is obviously a devastating command to run.
Mm-hmm.
So if you're going to do this, make sure you pay attention to what it's going to destroy, where it's going to destroy it. I only created this resource group earlier, but as you can see, it's going to be destroyed. And I am going to put a yes to get that destroyed. And it will no longer exist in my in my in my subscription on Azure.
Very cool. All right. Well, I think we're just about almost at the end. And I think it's time for me to do one of two things. One, we're going to get a little background music to kind of help finish us off. Let's do that.
Oh, and I did create this link in case anybody wants to look at remote state.
Sure.
aka.ms/tf-remote-state. That will take you to basically, it's exactly what I did earlier. That's the a tutorial on how to do remote backend on Azure for Terraform.
Sure. I'm going to go ahead and put that up right here.
Thanks, man.
No problem. Hey, that's really it for today. I super appreciate you joining me today, Zach. I think that I learned more, and I know I'm going to learn a whole lot more when you join me, not next Thursday, but the Thursday after once again. And like I said, we're going to bring on a couple of people from HashiCorp and learn even more than we have. So, Zach, thanks a lot for being here today, and I'm looking forward to talking with you again about even more Terraform stuff.
Yeah, man. Anytime. Sorry for the technical difficulties there right away, but thanks for holding it over until I could get back.
We did it. We did it live, and we got through it. So that's really it for us. We're going to say so long to everybody. Thank you so much for joining us here on AzureFunBytes. We'll be back next week for more cool stuff about Azure, fundamentals so that you can do the most with Azure you possibly can with just some of the quick bites. So let's wave goodbye, Zach.
Bye-bye.